In this video, I want to prove that every tree of order n and size m has m equal to n minus 1. That is, the size of every tree is one less than its order. The strategy here, let's talk strategy for a second. How am I going to prove this? Well, the fact that every non-trivial tree contains at least two leaves is going to help me a lot. The idea is that I can remove a leaf from the tree, and since it's not a cut vertex, the remaining graph will still be acyclic and it'll still be connected. Which means I can go from order n to order n minus 1 and preserve the property of being a tree. Now, whenever I can do that, whenever I can remove a vertex and still retain the properties I want, that means I can use induction. And so the idea here is to use induction. When I remove that leaf, all I'm going to do is remove one edge. So I've removed one vertex and one edge, and so this relationship between the size and the order will be maintained. So strategy is to use induction on the order of the graph and go from order n to n minus 1 by removing a leaf. That's the strategy here. So let's prove it. We're going to have to establish a base. So this is, let's see, if n equals 1, then G is necessarily just a single vertex, which is a tree, right? It's connected and acyclic. K equals 1 with m equal to 0, which is 1 minus 1. I think I even want to say if n equals 2, why not? Let's establish two things for our base. We don't really need it, but that's fine. If n equals 2, then the only tree of order 2 would have to be just the path, P2, or K2, same thing. Then G equals K2 with size 1, m equal to 1, which is 2 minus 1. So our base holds. We'll assume G is, we'll assume any tree of order n minus 1 has size m minus 2. Size m equal to its order minus 1, so size n minus 2. I'm not even going to use m because I'm going to use m later. We'll just say every tree of order n minus 1 has size n minus 2. So that's my induction hypothesis, and I'll give myself a tree of order n. Then G has a leaf. It has two leaves, but it has at least one leaf. It has a leaf, say U is a leaf. Then G minus U, since the leaves of a tree are not cut vertices, G minus U is connected. And since G was acyclic, well, if I remove a vertex, I certainly can't introduce a cycle into the graph that way. And so it's also acyclic. Hence a tree. Now, G minus U has order n minus 1. By our hypothesis, our induction hypothesis, it has size n minus 2. So when I removed that leaf, I also removed the one edge that came along with it. So G has order n and size one more than the size of g minus u. N minus 2 plus 1, which is equal to n minus 1. And that proves it. Isn't induction neat? All right, that's it for this video. Nice short one for you.